Everybody, welcome back to my channel. Today I wanted to go over ARP, the Address Resolution Protocol. It's a pretty important protocol to understand. I think it's very easy though to kind of gloss over it or get to a point in your career where you just take it for granted and maybe you forget exactly how it works and how important it is, and it can come back to bite you or harm you when you start troubleshooting. So I just wanted to take a few minutes to go over it again as a little refresher course and look at the actual packet captures and maybe go over some other aspects of ARP, such as IP proxy ARP. So with that being said, we're going to dive into this topology and look at a few scenarios. Okay, so a real quick definition of ARP is the Address Resolution Protocol, and it resolves layer 3 IP addresses to layer 2 MAC addresses. So this has to happen first before any type of communication can happen at layer 3, before any packets can be encapsulated. So ARP happens at layer 2, the frame layer. So it's going to send a frame. It's going to be two frames actually. There's going to be a broadcast ARP, and there's going to be a response to the intended recipient of that ARP. So we'll go over that right here when we do a ping from 192.168.1.1 to 192.168.1.2. Now this is a very simple test, and it's actually a really good test because it seems very simple, but underneath it there's actually a little bit of complexity where ARP has to happen before this ping can happen. So even something as simple as ping, ARP needs to happen before ping can happen. So let's get into this and first look at the router. So I'm going to look at R1 real quick here. So this is R1. It's a fresh router. I just booted it up. It has one entry in its ARP table. So I'm going to do that command again. Show ARP. It has one entry, and that is its own IP address on its own interface. So as soon as I configured interface gigabit Ethernet 1.0 with the IP address of 192.168.1.1, it loaded this ARP entry into its own ARP table and mapped its own physical hardware address. And this is never going to age out. As you can see, there's a hyphen there which indicates that this entry is permanent. It can never age out. I can't even delete this. So if I go in here and I say I want to clear that ARP entry, guess what? It's going to show back up. It's like your in-laws that you can't get rid of. It's just going to show back up again, okay? So that is what we expect to see on R1 because we haven't initiated any form of communication yet. So let's take a look at router 2. Router 2, we should expect to see two entries. We do 192.168.1.2, which is its own IP address to hardware layer 2 MAC address mapping, and then also 172.16.1.2, which is the other end of this segment here. So it has two ARP entries for its two interfaces. Okay? Now, let's go over our scenario. So, when we ping from 192.168.1.1 to 192.168.1.2, we need to have a route. So let's be good network engineers and verify that we have a route on R1 to 192.168.1.2. And we do. It's a directly connected route. It's the most believable route you can ever have. It's directly connected. The router knows it's there. It knows that the only other thing on the other side of this interface is 192.168.1.2, and it knows the interface to reach it out gigabit Ethernet 1.0, which is correct. So if it sends a packet out here, guess what? It's going to hit 192.168.1.2. It's the only thing that it can hit. However, as it stands right now, this is not going to work if I try to ping 192.168.1.2 because I do not have an ARP resolution. I do not have an ARP entry in router 1's ARP table. So it cannot craft a packet yet because in order to craft a layer 3 packet, you need a specific destination MAC address and destination IP address. So what's going to happen when I ping 192.168.1.2 from this router, a ping is not going to be the first thing that hits this wire. An ARP broadcast that asks for who is 192.168.1.2 is the first thing that hits this wire. A frame is the first thing that hits this wire, and then a subsequent response back from 192.168.1.2 saying, I have that IP address, this is my MAC address, which allows R1 to populate its ARP table. Now router 2 populates its ARP table with that original response. It doesn't need to send one back. And now both routers have an ARP entry for each other, and packets can be crafted with a specific destination MAC and IP address. So let's actually do this experiment now and fire up Wireshark to take a look at the packet capture. All right, so I have Wireshark loaded up, and it's pretty dormant right now. So we'll come back to that in a second. Let's kick off this ping. All right, so you can see the ping looks weird. Times out at first. That is generally regarded as the ARP process happening in the background. That's why the ping times out first, and then it resolves. It has that ARP entry now, and then now it can craft those packets, and the ping successfully takes place. So let's look at the Wireshark of this. So the first thing I want to do is filter on ARP. And you can see it's very simple. It's 2 frames. A source, which is coming from the sender MAC address, right? Router 1 knows its MAC address. It knows its IP address. The target MAC address, however, it doesn't know. So it's going to broadcast it. So on this segment right here, it's broadcasting to anybody that's listening. But the only person that's going to respond, or the only thing that's going to respond, is whatever has 192.168.1.2. It's the only thing that's going to respond. And guess what? It did respond. And it says, hey, this is my MAC address now, the sender MAC address. So this is from router 2's perspective, sender MAC address, sender IP address. This is my IP address. And this is the target came from that original frame, right? And then the target address of the original router 1's original request. So it's really simple. There's a who has, tell 192.168.1.1. So who has this? Tell me. And then the response back, I have it, and I'm at this MAC address. So now, both router 1 and router 2 should have populated ARP tables. So let's go in and verify that. And they do. 192.168.1.2 is matched to this hardware address. Let's verify router 2. And it does. 192.168.1.1 is mapped to this hardware address. So now these two are acquainted. They know each other. ARP does not need to happen anymore. If I send another ping, guess what? There's not going to be any ARP that happens because I already have an ARP entry. Okay? So no ARP is necessary. So that's the very basics of ARP and how it works on just a very simple segment. But it's very important to understand this before you start troubleshooting, because if you don't have the basics there, if you don't have that first step, you're not going to be able to get to the next step. So it makes no sense if you start troubleshooting at something that's the prerequisite hasn't happened in order for that to happen yet. So that's basically the whole point of this video, is to start thinking about the fundamentals, because it's easy nowadays, especially when you have a lot of things to distract you and a lot of buzzwords and newer technology that's out there, but underlying it is ARP. ARP still has to happen, and if you have a good grasp of the fundamentals, then you also have a good strategy to start troubleshooting, and it will prevent headaches and just make your life a lot easier. So that's the very basics of ARP.